Guys, this is chemistry, and in this video I'm going to show you how to come up with the chemical formulae of compounds. So the question is saying write the formulae for these compounds. So the first one, we have water. So water constitutes hydrogen and oxygen. So hydrogen, it has a valence of 1, and oxygen, it has a valence of 2. So these valences, they are going to swap each other. Then what is going to be formed is going to be H2O. So therefore, the chemical formulae of water, it is just H2O. And some compounds like B, which is carbon monoxide, we don't consider the valences. We just take what we have been given. Like for example, we have carbon, so which means here we have 1 atom of carbon. Then mono means 1. Oxide, it is an oxygen atom, so which means we are going to have also 1 atom of oxygen. That's mono. Mono means 1. So this one is the chemical formula of carbon monoxide. Another one, we also have this one, which is carbon dioxide. So as for carbon dioxide, we have 1 atom of carbon for this one, and di means 2, which means we have 2 atoms of oxygen. So carbon dioxide, it is CO2. So this one is the chemical formula of carbon dioxide. We also have sulfur dioxide. So as for sulfur dioxide, we have sulfur, 1 atom of sulfur. And we also have di. Di means 2. And oxide is coming from oxygen atom. So it's an oxygen atom. So di means 2. So which means we are going to have 2 atoms of oxygen. Then for E, we have sulfur trioxide. So sulfur trioxide, we have 1 atom of sulfur. Then 3 means 3. 3 means 3. So this 3 means 3 atoms. Now oxide is coming from an oxygen atom. So we have 3 atoms of oxygen. So this is how we write sulfur trioxide. Then F, we have sodium chloride. Sodium chloride, as for this one, we need now to consider the valences. So we need to consider the valences. Sodium, it has a valence of 1. Then chlorine, it is found in group 7. So elements from group 1 up to group 4, their group determine their valence. Then from 5 up to 8, for you to know the valence, you need to subtract from group 8. So chlorine is found in group 7. So for us to know the valence, what we are going to do, we are going to say 8 minus 7. Then we are going to get the answer as 1. So which means chlorine, it has also the valence of 1. Now these valences, they are going to swap each other. So therefore we are going to form what we call sodium chloride, which is Na1, then CH1. So we can just write it as sodium chloride, whereby here we have 1 atom of sodium and 1 atom of chlorine. So this is how we write the chemical formula of sodium chloride. Then as for G, which is magnesium chloride. So magnesium is found in group 2, and I was saying elements in group 1 up to group 4, their group determining their valence. So magnesium is found in group 2, which means it's going to have the valence of 2. Then we also have chloride here. So this chloride is coming from chlorine. So here we just have chlorine. So chlorine is found in group 7. So for us to know the valence, we are going to say group 8 minus group 7, which we are going to get it as 1. So these valences, they are going to swap each other. So therefore, we are going to have magnesium with 1 atom here, then chlorine with 2 atoms. So therefore, we can just say magnesium chloride with a 2 here, whereby here we are going to have 1 atom of magnesium and 2 atoms of chlorine. So that is how we write the chemical formula of magnesium chloride. Then the next one, we have hydrogen chloride. So hydrogen chloride is the combination of hydrogen atom and chlorine. So we have hydrogen with a valence of 1 and chlorine with a valence of 1. So when these valences swap each other, we are going to have H with a 1, then also chlorine here with a 1. So therefore we can just say hydrogen chloride which is also known as the hydrochloric acid. So this one is the chemical formula of hydrochloric acid or hydrogen chloride. Then we have methane. So from organic chemistry, when you talk of the term meth means one carbon atom, okay? Meth means one carbon atom. And when you talk of alkanes they end in a suffix of ane. Ane. This one is going to tell you that this one is an alkane. Alright, so the chemical formula for all alkanes, it is CnH2n plus 2. So this one is the chemical formula of alkanes. So since this one it is methane and it is ending in a suffix of ane, so it is an alkane. So now since it is an alkane, we can say meth means one carbon atom. So where we are having Na, this N is representing the number of carbon atoms. So we are going to say C1H2 open bracket 1 close plus C2. Then here we are going to have CH4. Since 2 multiplied by 1, we are going to get 2. 2 plus 2, that is 4. So this is the chemical formula of methane. Okay, so we have J, which is the ammonia. So some of the compounds, you just need to know their chemical formula. There is no need of you finding like the valences or whatever. So as for ammonia, so ammonia, it is NH3. Then when you talk of ammonium, it is NH4. So there is a difference between ammonia and ammonium. NH3, it is ammonia. So this one is the ammonia. Then NH4, it is the ammonium. That's the difference. The next question. So this one is saying, this diagram represents a molecule of a certain gas. A molecule of a certain gas. So we have the diagram of this certain molecule. So now this molecule, it is having one nitrogen atom. So we can say N. Then 3 hydrogen atoms. This one, and also this one. So it has 3 hydrogen atoms. So it is NH3. Now the first question is saying, name the gas and give its formula. So what is the name of this gas here? So this one is called the ammonia. So you need to say ammonia. Then after saying ammonia, we need to write its formula. So its formula, just get this one, the same one that I've written here. That's the formula. Then B. What do the symbols, the dot and the cross, represent? So these, they are just representing the electrons. Okay, so the dot and the cross, they are just representing the electrons. And then for C, which type of bonding holds the atoms together? So they're talking about the same molecule here. So nitrogen is a non-metal, and also hydrogen here, we are just going to consider it to be a non-metal. Okay, so hydrogen can be a metal or a non-metal. So on this part, we are just going to consider it to be a non-metal, because this one is falling under ammonia. Ammonia is a non-metal, it's a gas, so it's a non-metal. Now, the type of bonding that exists between two non-metals, it is called molecular bonding or covalent bond. So we are going to say a covalent bond or molecular bond. So that is the type of bonding that is holding these atoms together. Then the type of bond that exists between a non-metal and a metal, it is called ionic bonding. Question D. Name another compound with this type of bonding. So we can talk of water, which is H2O. So H2O, it has the same bonding as the ammonia because it is containing hydrogen and the oxygen, which are non-metals in this case here. Apart from this one here, we can also talk of methane. We can also talk of what? Methane. Methane, it is CH form. This one here, it has also the same type of bond as the ammonia. So that was the last one. Thanks for watching.